If you pull out your phone right now and draw a straight line from Stonehenge to the Great Pyramid, your map will show a random diagonal slash across the globe, but that pocket map is actively hiding the spatial logic of the ancient world. The distortion starts with the tools we use every day, the standard WGS84 Greenwich Prime Meridian and Mercator projections. WGS84 is a standard coordinate reference system used globally for cartography and GPS tracking. These are strictly 19th century naval tools, engineered specifically for sailing. To help ships keep constant compass bearings, these grids stretch and warp distance, area, and crucially, great circles. A great circle is the absolute shortest path between 2 points over the Earth's true oblate curvature. If early builders aligned their monuments using the actual physical curvature of the planet, measuring their work on a flat naval spreadsheet erases their mathematical intent. This table contrasts our current naval baseline with a proposed geodesic prime meridian. By resetting the global 0-0 origin point away from the UK and onto the massive geological bullseye of the Richat Structure in Mauritania, a different worldview emerges. The literal center point of our coordinate system is the variable masking a mathematically rigid macrostructure embedded in global geography. Shifting the Earth's origin to Richat snaps the scattered plot of global rooms into a deliberate, radial pattern. This geometry is the polar spoke wheel model. The Richat acts as the central hub, directional spokes provide rigid support, and concentric distance rings form the webbing. We see specific geographic clustering. A single unified Northern European ring perfectly connects Karnak, Stonehenge, and Newgrange along the exact same arc. The most statistically prominent directional spokes sit at specific bearings. The Afro-Eurasian alignment cuts directly through the Great Pyramid of Giza and Petra, while the American and Pacific alignment hits the Nazca Lines and Easter Island. This graphic shows the Great Circle bisector. On a geodesic framework, the Nazca trajectory and the Giza trajectory are a single, continuous great circle, directly bisecting the planet through the central Richat pivot. The mathematical probability of humanity's most famous monuments landing exactly on these intersecting nodes by pure statistical accident is vanishingly small. This geodesic lattice implies these ancient sites were phase-locked hardware components within an integrated planetary system. This 3-panel schematic details the Planetary Motherboard. It represents the formal framework proposed by systems architect Allan Christopher Beckingham, which models this physical geodesic lattice as an active, distributed analog computation system. Beckingham classifies these sites as proto-coordination architectures built to compute civilizational complexity. Within this model, the Giza Plateau functions as the network's primary localized interface and I/O transmission bus. The internal architecture of the Great Pyramid encodes a specific data pipeline. The subterranean chamber handles state initialization, the Grand Gallery provides signal amplification, and the King's Chamber executes coherence verification. The Nile River acts as the primary system bus, facilitating the transfer of data and energy to tiered processor arrays like Khufu, Khafre, and Menkaure. This graphic depicts the massive underground labyrinth of Hawara operating as the back-end computing power. It functioned as the central processing unit of the entire analog network. Hawara's highly partitioned restricted access architecture was mathematically designed to dissipate entropic load. It regulated the stability of the global system by tightly controlling the flow of information and physical access. These ancient stone servers were uniquely engineered to absorb and distribute systemic civilizational stress, functioning as persistent, load-bearing coordination nodes. But hardware requires software. We must look at the dynamic operating system that regulated this network. System stability is dictated by the Genesis ODE. ODE stands for Ordinary Differential Equation, which is a mathematical formula used to describe how a system changes dynamically over time based on its current state. This equation shows how the network constantly fights entropic drift, represented by delta, and disruptive environmental stress to maintain a globally stable coherence threshold, mathematically defined as exactly 0.87093. The system operates in one of two distinct regimes. When functioning correctly, energy distributes in a smooth state called laminar flow. When the coherence threshold drops, the network fractures into a civilization collapsing state called turbulent decoherence. To run this complex operating system and prevent collapse, operators required a specific set of manuals. The Egyptian Book of the Dead structures ritual sequences in a manner consistent with procedural logic. Mummification represents state initialization, while the weighing of the heart acts as a coherence validation test to ensure the system remains within its stability threshold. Ritual and myth functioned as highly encoded diagnostic protocols, providing the procedural logic necessary to prevent the catastrophic decoherence of the global machine. The ultimate test of any scientific system's architecture is its ability to predict missing data and generate testable hypotheses. This chart illustrates the core objective of the CGD framework. It moves archaeology away from descriptive surface surveys toward a predictive computational science aimed at uncovering hidden geometry. The framework's primary diagnostic tool is antipodal mirror math. Diagram 2 shows how this logic takes the coordinates of known sites and mathematically flips them 180 degrees through the Richat center to find their exact opposite. As this diagram shows, the algorithm must apply bearing and radius offsets to generate a calculated search zone. This accounts for the Earth's oblate spheroidal shape, ancient surveying tolerances, and millennia of tectonic plate drift. We can prove the algorithm's validity by testing its success rate on known sites. That's detailed here. A predicted coordinate labeled node N0638 landed a mere 15.68 kilometers from the Nazca lines. By combining rigid geometric mirroring with these probabilistic search corridors, the framework accurately reconstructs the internal logic of the Earth's missing architecture. The algorithm generated exactly 1,152 total geodetic intersections. An isolation filter strips away any intersection falling within 300 kilometers of a known site, revealing exactly 927 blind spot candidates. Within the motherboard model, these missing nodes serve a specific systemic function. They are mathematically dictated latent coherence sensors and network load balancers. This framework provides a targeted roadmap for discovery, directing future searches into the most hostile, unexplored regions on Earth. The highest value target classifications are clustered in extreme environments, with dozens of nodes positioned deep within the Pacific voids and submerged along the Atlantic Ocean ridges. Crucially, 36 predicted structural nodes fall below -60 degrees latitude, buried deep beneath the Antarctic subglacial ice shelf. To validate this network, the next empirical steps require executing targeted deep-sea bathymetric anomaly hunting and deploying ground-penetrating LiDAR over these exact subglacial coordinates. LiDAR stands for Light Detection and Ranging, a remote sensing method that uses pulsed lasers to map structures hidden beneath surfaces like ice or dense canopy. If this mathematical symmetry holds, an unobserved structural node is sitting beneath a mile of polar ice right now, waiting for us to trust the math and look.